Lagrange's interpolation formula. In this video, I am going to show you first of all the easiest and the simplest way to derive this formula, and secondly I will show you how to use this Lagrange's interpolation formula in your data for finding the unknown values. So starting from its derivation of the formula, that is the most simplest way to derive this formula. Let y is equals to f of x be a function which takes n plus 1 values y0, y1 up to yn, corresponding to x0, x1 up to xn. Let us consider the polynomial of the form Now, which form of polynomial they are considering here? The polynomial equation y equals f of x, that is equals to a naught times x minus x1, x minus x2 up to x minus xn plus a1 times x minus x0. Now a1, so don't write x1 here, x minus x2 up to x minus xn plus a2. Now this is second term. For that you don't have to write x2 now. So x minus x0, x minus x1, x minus x3 up to x minus xn plus up to so on up till an x minus x0, x minus x1 up to x minus xn minus 1. You see, for the naught value you haven't included x0 here. For 1 value you have not included x1. And for 2 value you haven't included x2 here. And same for an, you have not included xn here. Now this is your polynomial equation. Putting x is equals to x0 and y is equals to y0 in this equation, in equation number 1. We will get from here, now this y will become y0 equals x equals to x0. If you put x is equals to x0 here, this term will become x0 minus x0. So this term will be 0. This term will be 0, this term will be 0. All the terms that contains x0 already, all the terms will be 0. And only I will be left with this one. So y0 equals a0 times x minus x1. Replace x with x0. x0 minus x2 up to x0 minus xn plus 0 plus 0 plus up to so on. So from here I can get the value of a0. And what my a0 will be? A0 will be equals to y0 divided by this coefficient, y0 divided by x0 minus x1, x0 minus x2 up to x0 minus xn. Similarly, you have to do what? Putting x equals to x1 now and y is equals to y1 in equation number 1. Then from there we will get a1 equals to y1 divided by x1 minus x0 into x1 minus x2 up to x1 minus xn. Similarly, you will put x is equals to x2 and y is equals to y2 in equation number 1, and we will get from here a2 is equals to y2 over x2 minus x0, x2 minus x1 up to x2 minus xn up to an, that will be equals to yn over xn minus x0, xn minus x1 up to xn minus xn minus 1. Now you got all the values for these coefficients. Which coefficients? A0, A1, A2, An. Using all these values of coefficients in this equation number 1, we will get the Lagrange interpolation formula. So, using values of A0, A1 up to An in equation number 1, we will get y equals to f of x equal x minus x1, x minus x2 up to x minus xn divided by x0 minus x1, x0 minus x2 up to x0 minus xn at y0 plus x minus x0, x minus x1, x minus x2 up to x minus xn divided by x1 minus x0, x1 minus x2, x1 minus x3 up to xn1 minus xn at y1 plus up to so on until x minus x0, x minus x1 up to x minus xn minus 1 divided by xn minus x0, xn minus x1 up to xn minus xn minus 1 yn. This is our Lagrange interpolation formula. Now, what is the advantage of Lagrange interpolation formula as compared to the Newton's Gregory forward or the backward difference formula? Basically, in the Newton's Gregory forward and the backward difference formulas, we have always the equal intervals between the points. We have equal distance intervals. But you can use the Lagrange interpolation formula whether you have the equal intervals or you have the unequal intervals. So this is the advantage of using this formula. You can apply it on the unequal intervals as well. Now it has some drawbacks as well. This formula has a drawback that if another interpolated value is inserted in the table, then interpolation coefficients are required to be recalculated. This is the only drawback for the Lagrange interpolation formula. So let's move on to the example. Our example is you are given with some data and you have to calculate the value for y10. Now what is this y10? This y10 is basically yx. So you basically have to find out the value of y at x is equals to 10. Or sometimes it's also written as like find f of 10. F of 10 means you are given with the x equals to 10 value and you have to calculate your f of x at this value. So when you are given with f of x, then you will write here as f of x0, here f of x1, here f of x2 and this f of x3. And what are this? This is y0, f of x1 is y1, f of x2 is y2 and f of x3 is y3. Now from the table, this value of 5 is your x0, this is x1, x2 and x3. And these values are y0, y1, y2 and y3. Using this data in this formula, Lagrange interpolation formula. Now how you have written this formula? First of all, you have to write the coefficient for y0. When you are writing the coefficient for y0 or f of x0, you have to take this x0 in your denominator and minus all the x values from it. x0 minus x1, x0 minus x2 and x0 minus x3. And in the numerator, don't write x0 now. And write all the values irrespective of the x0. X minus x1, x minus x2, x minus x3. Now same you will write here with the coefficient of y1, x1 minus x0, x1 minus x2, x1 minus x3. Now just skip the x1 here and write all the other values of x minus with this x minus x0, x minus x2, x minus x3, and the rest of the things as like this. Now fill all the values. What is your x? Your x is 10, this one or this one. And this is x0, x1, x2, x3, y0, y1, y2, y3. Put the values, all these values in this equation, Lagrange interpolation formula. We will get here y10, x is our 10. y10 will be equals to 10 minus 6, 10 minus 9, 10 minus 11. I'm just filling the data from the table. And here I will have 5 minus 6, 5 minus 9 and 5 minus 11 times here we have 12. Plus here I will write 10 minus 5, 10 minus 9, 10 minus 11 divided by x1 minus x0, and all these terms will give us 6 minus 5, 6 minus 9, 6 minus 11, and what is our y1? y1 is 13 plus this third fraction, that is basically equals to 10 minus 5, 10 minus 6, 10 minus 11 divided by 9 minus 5, 9 minus 6, 9 minus 11, and my y2 term is here 14 plus the last fraction. I have to fill my last fraction, that is 10 minus 5, 10 minus 6 and 10 minus 9 divided by 11 minus 5, 11 minus 6, 11 minus 9, and what is my y3? My y3 is 16. Now open all these terms, solve it. After solving, I will get here 2 minus 13 over 3, 2 from the first fraction, minus 13 over 3 from second fraction, plus 5 over 3 from the third fraction, and the fourth fraction will give me 16 over 3. After simplification, I will get here 44 over 3, that is equals to 14.7. So in this way, you can find the value of y at any of the value of x given in the question.